Hi everyone. We're going to go ahead and start today's lesson by evaluating limits, and more specifically limits that involve graphs of functions. So we'll start out with number 1. We want to take the limit as x approaches 4 of f of x. That's the way that you read that. And so we want to just head towards 4. We'll do that now. Obviously you can see x equals 4 as a vertical dotted line. As you head towards it, you can see that the graph goes sky high, which means that the answer to number 1 is simply going to be positive infinity. Now, normally we'd want to see what's happening when we head towards 4 from both directions, but this graph is not defined to the right of 4, so therefore infinity becomes the answer. Okay, number 2, it's the limit as x approaches 2 of f of x. Well, if you're approaching positive 2 here, we don't know which side we're coming from. If we're traveling along this path, you can see that we're approaching a height of 3. But if we're heading towards 2 from the right and we're on this path, we're heading towards a height of 1. And 3 and 1 are not the same number, obviously, and so therefore there is no limit at 2. The limit does not exist. And the abbreviation for does not exist is DNE. That's used quite often, because spelling out does not exist is time-consuming, and this happens enough that people are going to realize what DNE stands for. The only way to have a limit of a graph is if the left and right-handed parts of the graph head towards the same location. They don't have to touch each other there. There could be an open circle. For example, let's say this left-handed side went like so, and it came down here instead, and also hit the point 2, 1, but there was an open circle there. Let's say that didn't exist. There is a limit there, and the limit is the height of the graph, which is 1, even though there's nothing filled in. Okay, we're going to formalize this in a little while, but for now, know that the limit is what you expect when you approach a point, not what you get when you're actually there. So here, from the right, we are heading closer and closer to a height of positive 1. And along this curve from the left, we are heading towards a height of positive 1. Since we're heading towards a height of positive 1 from both sides, the limit would have been 1. But removing everything that we just wrote, you can see that we're heading towards 2 clearly different places. We're heading towards 1 and 3, which are not the same number. Therefore, the limit in number 2 does not exist. Number 3 wants the limit as x approaches 0 of f of x. Well, if x approaches 0, you're going to be right here. Even though that point is not filled in boldly, the point still is there. The answer is going to be 2. You're heading towards a height or a y value of 2 as x approaches 0. And again, that's from both sides. They both have to approach 2, and they do. 2 is the answer. All right, number 4. We're back to x equals 2, but this time, notice the word limit is not there. We simply want f of 2. What is f of 2? In other words, along this dotted line through x equals 2, where is it filled in? And the answer is right here, and that corresponds to a height of 3. So, just to be clear, the limit doesn't exist at x equals 2, but f of 2 does exist, and that is a value of 3. All right, let's move on to some more. Again, the best way to understand limits is to do a bunch, and then, like I said earlier, we'll formalize the definition. All right, now you're going to start to notice what we refer to as one-sided limits. And number 5 has one. You can see there's this superscript right here. It's not a negative 5. It's a positive 5. X is approaching positive 5. From the left is what that little negative refers to. So that's approaching positive 5 from the left. So you're plugging in numbers like 4.9, 4.91, 4.92, 4.999. You're not actually getting to 5, but you're approaching it. Well, 5 is right here. This is x equals 5 along this dotted line. So if you approach that from the left-hand side, you're going to be coming along this particular piece of the f of x function. You are approaching an answer. Yes, there's an open circle there. That's okay. A lot of times textbooks will try to fool you with an open circle. Are you getting closer to a certain height as you head towards 5? And the answer is yes, you are. And that height is -3. So the limit is -3 as x approaches 5 from the left. Hey, by the way, if you approach 5 from the right, it's also going to be -3 because they both are heading to that location, the point 5, -3. Even though it's not filled in, it still is a limit. On to number 6, we have the limit as x approaches 2 of f of x. Again, it doesn't say from what direction. If we come at x equals 2 from the left, we'll be approaching a height of +1. In fact, it is filled in there. But if we approach x equals 2 from the right, we have an open circle at -1. And the answer cannot be +1 or -1 simultaneously. Therefore, once again, the limit does not exist. DNE. You may notice that we have some discontinuity here. There are 3 types of discontinuity. Maybe you remember that from pre-calculus. This, at 2, is what we refer to informally as jump discontinuity. There is literally space between the 2 branches of the graph. Jump discontinuity will never have a limit. That'll always be it does not exist. Infinite discontinuity also does not exist. So let's say that you had part of the graph that went to positive infinity, like so. The other part of the graph went to negative infinity. That obviously doesn't have a limit either. The third type of discontinuity is point discontinuity, also referred to as removable discontinuity. That would be where just a single point is out of place, like here at 5. That's okay. You can have a limit there because coming towards that point from the left and coming towards that point from the right, you're approaching the same height. Okay, so a rule of thumb, point discontinuity will still spawn a limit. Jump and infinite will not. And again, if you do not see the superscript, notice right here on number 6, there was no plus or minus. It was just x approaching 2. You have to try both sides in that case. If you have a minus, or like number 7, a plus, then it's a one-sided limit. You only have to come at it from one direction. All right, let's try number 7. Okay, we want to come towards -3 from the right. That's what the plus means. So we're heading towards -3, but we're doing so from the right. Again, -3 is right here. X equals -3. Since we're coming towards this dotted line from the right-hand side, we are traveling along this portion of the graph. Again, open circle, no worries. We're still heading for an answer. And that answer is +5, because that's how high we would have been had we actually reached -3 and the circle had been open. Filled in. All right, number 8. The limit as x approaches 0. I'll just use a different color on this one. I'll use red. Again, if you're heading towards 0, it doesn't say which side we're coming from, so we have to agree to come from both sides. But in either instance, you're heading for the point 0, 2, and therefore the limit is 2. So the right and left-handed limits have to be equal for the overall limit to exist. And in number 8, that was the case. All right, 4 more examples. We'll wrap up this section. This is a very quick section. It is informal, and like I mentioned a couple times before, we'll formalize it a little later on here. But we want to take the limit as x approaches 5 of f of x. Same drawing as the last slide. Again, +5 is right here. It does not say that we're coming from the left or from the right, so we have to come from both directions. But you can see that it does not matter which way we approach x equals 5, we're heading for a height of -3 either way. All right, number 10. The limit as x approaches 2 from the right. Let's put some green on this one. If I head towards +2 from the right, I'll be heading this direction along this piece of graph, and you can see that I'm heading towards a height of -1. I don't actually get to the point to -1. It is an open circle. But again, the limit is the journey, not the destination, as I like to say sometimes. All right, number 11. 2 more to go. This time we are approaching -3 from the left. Again, that second minus means we're coming from the left-hand side. And so we're traveling along this curve, heading towards -3, and we stop. And we actually ended up at a location, and that location has a height of -4. It's the point -3, -4. Again, the limit is simply the y coordinate of where you're heading. Now, that was a negative, which told me that I had to be along this portion of the curve. Had this been a positive, I would have been on this portion of the curve instead, and I would have gotten an answer of +5 instead. Now, obviously, -4 and +5 aren't the same thing, and so last but not least, surely, if we say you're approaching -3, but we don't specify whether it's from the left or the right, you have to come at it from both sides. And you've already seen that +5 and -4 clearly are 9 spaces apart. That's a major jump discontinuity. So for number 12, once again, the limit does not exist. The overall limit does not exist because the left and the right-handed limits are not equal to each other. All right, that's it for figuring out how to find limits graphically. The next lesson, we're going to go ahead and find limits analytically, so we're going to have formulas instead of pictures. I'll be a little bit more exact in how I define what a limit actually is, and then we'll finish that next lesson by looking at something called the squeeze theorem, which is becoming more and more prevalent on AP exams. So until we meet again, we'll see you guys later. Take care.